Hello everyone, my name is Titus and today we are going to derive expression for escape velocity. So, when a body is thrown upward, you know that when a body is thrown upwards, its velocity goes on decreasing. Due to the gravitational pull of the earth. Pull of the earth. As a result, at some point of its trajectory, that is the highest point, the velocity becomes 0 and it returns back to the earth's surface, and after that it falls back to the earth's surface. If gradually the velocity of projection is increased, then for some value of velocity, the body will escape the Earth's gravitational pull and it will not fall back to the earth. That is, and it will not return back to the earth. Then we will say that the body has escaped from the Earth's gravitational field, and the velocity with which the body is projected, we call it to be the escape velocity. So, the velocity with which this body was projected would be the escape velocity. So, for different planets, the value of escape velocity is different, and for the Earth's surface, the escape velocity is approximately equal to 11.2 km per second. That is the escape velocity on the Earth's surface. That is any body, whether it's small or big, massive, if it is projected upward with a velocity of 11.2 km per second, it will not return back to the earth. Similarly, for the moon, the escape velocity is 2.38 km per second is the escape velocity on the moon. So this So this explains the reason why there is no atmosphere on the moon. Okay. So let us now derive expression for escape velocity. So let us say a body of mass m be projected upward with a velocity ve from the Earth's surface. And let at any instant its distance from the Earth's surface be distance from the Earth's surface, sorry, not from Earth's surface, from the center of the Earth, be x. Okay. So let us draw the diagram for this. So let us say this is the Earth's surface, this is the Earth, this is the center of the Earth, and let us say the body is projected upward, this is the radius r, and let us say at a given instant the body is at this point, m is the mass of the body, and distance from here to here, let it be x. And let us say this point is infinity, that is the point where the body will not experience any gravitational pull due to the Earth. So here x is a value which is greater than or equal to r and less than or equal to infinity. Okay. So at this instant, if m is the mass of Earth, then we can write F is equal to g capital M small m divided by x square. So this is the gravitational pull due to the Earth when the body is at a height of x from the center of the Earth. So if we displace this body by a small amount, let us say dx further, then we have to do some work. So then the work done will be equal to, since the gravitational force F will act downward, so I have to apply a similar force in the upward direction, so it will be negative of this gravitational force, and we will write it F. So work done will be minus of F into dx, or that is equal to minus of g capital M small m divided by x square into dx. And integration we are starting from the surface of Earth. So on the surface of Earth the height is r, and then we have to reach to infinity. Okay. So integrating it, will get work done will be equal to minus of g capital M small m into dx by x square integration r to infinity, or that is equal to minus of g capital M small m into x to the power minus 2 plus 1 divided by minus 2 plus 1, it will come to g capital M small m divided by x. So substituting, we will get g capital M small m into 1 by infinity minus 1 by r. We know that 1 by infinity is equal to 0, so we'll get it as g capital M small m into 0 minus 1 by r, or that will be equal to minus of g capital M small m divided by r. So this is the work done, and so this work done will be storage potential energy when the body reaches the height of infinity. So now we know that we have taken the velocity of the projectile to be so let v be the velocity of projection of body from Earth's surface as a result we can write the initial kinetic energy initial we can write that's equal to mv square by 2, and finally when the body reaches the highest point the final velocity, let us say to be v final, that will be equal to 0. So the final kinetic energy will be equal to mvf square by 2, or that is equal to m by 2 into 0, or that is 0. So from law of conservation of energy we can write if we take this point to be A and take this point to be B, so at point A we will find that the total energy will be kinetic energy and the total energy here will be potential energy. So from law of conservation of energy, from law of conservation of energy, we can write energy at A is equal to energy at B, or we can write mv square by 2 will be equal to g capital M small m divided by r with a minus sign. Here we should also remember that this will be minus mv square by 2. Why? Because our change in kinetic energy will be equal to kinetic energy final minus kinetic energy initial. That will be equal to 0 minus mv square by 2. Okay. So simplifying this equation we can write mv square by 2 is equal to g capital M small m by r. We cancel off m and then we have v is equal to 2g m by r whole under root. We know that g is equal to g m by r square. So we can multiply r and divide by r. So it comes to v is equal to 2 gm by r square into r under root, or that will come to 2gr under root. So this is the expression for escape velocity. Now if we put the value of g is equal to 9.8 meter per second square and r is equal to 6.4 into 10 to the power 6 meter, we get v is equal to 2 into 9.8 into 6.4 into 10 to the power 6 whole to the power 1 by 2, which will come to 11200 meter per second, or v will be equal to 11.2 kilometer per second.